talked about multiple ways on how to solve and graph linear equations. So let's talk about this idea of solving linear systems by graphing. And this is just going to take that idea of graphing lines to another level, because when you talk about a linear system, you're talking about two or more linear equations where you have the same variables. And it's really when you're essentially talking about the same things when you're graphing the same things. And this will make more sense as we get more deeper into it. So first, let's just start off and talk about a couple different ways that we might graph, or even how we might find a solution to a linear system. So the first thing we want to do is we want to look and we want to say which we want to understand sort of what this idea of what a solution is. So what I want you to do here is I want you to try A, B, C, and D of these points, okay? And I want you to plug them into each of these equations, all right? So you're going to start with this maybe A and plug it in here, and you're going to see if it works, and then try B, and again C and D. And I want you to try all of them and plug it into both the first equation and the second equation, okay? And what I'm looking for here is which solution is going to work for both of these equations. So why don't you go ahead, pause the video, and try that. All right, hopefully when you did is when you plugged all this in, you realize that 1 comma 5 is actually the solution here. So you end up with 1 and 5, right? So let's see, negative 5 times 1 is negative 5, and then plus 5 is 0. And then you have another thing here where you have 1 times 5 and 5, so 5 plus 5 is equal to 0. Okay, so you're basically looking at two different equations where the same solution works for both. So let's take a look at what this looks like actually on a graph. So here we have two different graphs, or we have the two equations, and one's in red and one's in blue. And what I'm going to do is, to start with here, is because it's in standard form, I'm going to go ahead and use intercepts to do this, okay? And what I'm going to do is I'm going to solve for both x and y, and I'm going to find the intercept of both, okay? So let's start off with this first one, and let's look and say, okay, well, what is the x-intercept here, right? So if x, right, if x is, I'm sorry, let's find the x-intercept. So if y is 0, then what is x going to be? Well, negative 5 times what is 0, right? So I've got negative 5 times 0 is, or what times, sorry, negative 5 times what is 0, and it's going to be 0. So if y is 0, x is 0. That's one intercept. Now let's find the other one. Well, the other one actually also happens to be where y is equal to 0. So now we get a little bit stuck, and so what we're going to do here is let's go ahead and just plug in a point. So I know here is if I plug in 1, right? So if negative 5 times 1, I get negative 5. In fact, let's go ahead and do this. If I plug in, I'm going to basically do a input-output table. So if negative 5 times 1, okay, plus y is equal to 0. Okay, so negative 5, that's negative 5 plus y is equal to 0. So I'm basically saying negative 5 plus what number will get me to 0? Well, that means y is going to have to be equal to 5. So I know that another point here is going to be, right, I plugged in x was 1, so over to x is 1, and y is equal to 5. So 1, 2, 3, 4, 5. Okay, that's one. And then I'm going to go ahead and I'm going to draw a line here. Okay, I'll draw a line through these points. Okay, and let me fix that one a little bit. Okay, we could go through there nice perfectly. Okay, perfect. Okay, so that's my red line. Let me fix this bottom one just a little bit. All right, looks good to me. Now, let's go ahead and let's solve the blue one. And let's go ahead again and let's use intercepts. Okay, so I've got x, let's do 5 times what, or make y 0, and x is going to be equal to 2. Oops, let's make this blue. Okay, x will be equal to 2. All right, and then if x is 0, y is going to be equal to 10. Well, looks like maybe I didn't go quite far enough. So let's kind of do this. We'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is going to kind of take me out. You can't see it, so but I'm going to graph it anyway. Okay, and hopefully you already know where this is going to take us through. Whoops. Okay, as I draw this line through all the way up there, okay, it's taking me actually through 1 comma 5, which we already found earlier. That was the solution, right? So what I'm looking to see is basically where do these lines intersect? Well, they intersect at 1 comma 5, and that's a solution because this is a point that lies on both of these lines. All right, well, let's take a look at it. Let's try it maybe, oops, sorry. Let's try it another way here. Let me make this graph a little bit smaller so that it's going to fit on here. Okay, so now let's try it. And this time what I'm going to do is instead of using y-intercepts or intercepts, is I'm going to do slope-intercept. Okay, so I'm going to take it from standard form and I'm going to turn it into slope-intercept form. So I have negative 5x plus y is equal to 0. Okay, so I'm going to move the 5x to the other side. So I'm going to get y is equal to 5x. Okay, so let's look at this, and if I'm looking to know that my slope is 5 over 1, and I know that my y-intercept is going to be 0. So I'm going to plug in 0 here, and then I'm going to use my slope of 5 up. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. And then I can go ahead and draw a line here, okay, down through, and that looks pretty good. Okay. Next, let's go ahead and do 5x plus y equals 10. And let's go ahead and we'll move the 5x to the other side. So I get y equals negative 5x plus 10. So I have a slope of negative 5 over 1 and a y-intercept of 10. So let's start at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. And my slope is negative 5 over 1. So I'm going to go 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. And I have another line there that will intersect, right? So we knew where it was going to intersect, but now we just have another way of getting to it using slope-intercept form, okay? And again, same answer, okay? These two connect at 1 comma 5. Okay, now your turn. Why don't you go ahead and graph this one? Go. Okay, I'm going to start off with the blue one. This one, to me, I would use intercepts. Okay, they just looks easier. So 2x. If what's the y? The x-intercept is going to be 2, right? This goes away. I got 2 times what equals 4. So my x-intercept is 2. My y-intercept is 4. 2, 3, 4. Okay, I can draw my line from here. Oh man, this pen is not working very well. Okay, line goes through there. Now let's try the other one, the red one. So I'm going to again, let's see. This one I'm not going to use intercepts, and the reason I'm not going to use intercepts here is because I'm going to, if 2y is equal to 3, and if I divide that, I'm going to get a decimal. I don't really want a decimal there, so let's go ahead and solve it. So what I'm going to do is I'm going to say 2y is equal to, and what I'm going to do is move this to the other side, so x plus 3. Well, this is not going to be all that friendly anyway, but it's okay. We'll divide everything by 2, right? Divide this by 2, divide this by 2, divide this by 2, and I'm going to get y is equal to 1/2 x plus 3 halves. Okay, well 3 halves is not too bad. So what I'm going to do is that's 1.5 here. Okay, and now what I'm looking for, now my slope is down 1 over 2. Well, that's not the most ideal situation here, but you're basically just, if we go down 1, I'm going to go right 2, and then I'll go down 1 and right 2. Whoops, nope, I'm going the wrong way. I'm supposed to be going up 1, right 2, up 1, right 2. Okay, now notice it's still 1 unit, right? Even though I'm at half here. I'm still going up 1, so it's 1.5, up 1, I go to 2.5, and then I still travel 2 to the right. And then let's go ahead and we'll draw this line. Straight through, and it looks like I'm going to intersect right here at 1, 2. Okay, and what we should do is we should plug that in. So we should do 2 times 1 plus 2 is equal to 4, right? And plugging that, in fact, let's do this. In order to maintain some consistency here, let's make that blue. Okay, and then we're going to check to see if this works. So I've got 2 plus 2 equals 4. That's like the early basic problem, right? 2 plus 2 equals 4. That one checks out. Let's try the red one with 1, 2, and we're going to get -1, and x is 1, plus 2 times 2, and we're going to see, does that equal 4? Okay, well, -1, wait, what did I do wrong here? -1, if x is 1, 2, oh, sorry, it's not 4. It's 3. Okay, so -1 plus 2 times 2 is 4 equals 3. Does that work? Yes, it does. That's my solution, okay? There you go. There you have it. That's how we do it with graphing. This is why we need to know how to use those two different forms of graphing. Whichever one, if you really got stuck, you could use input-output table. It really wouldn't make a difference. You would get the same lines. You'd get the same intersection. And, you know, if you get stuck, try a different way. Try one way, get stuck, try a different way, get stuck, go back to input-output table, and you'll be fine. Okay, make sure you bring your notes to class, and we will talk a little bit more about this next time we meet.